Welcome to Part 8 of the Guided Tour series. In this section, we will add the next level of detail to our functional decomposition. We will derive the integrated system behavior while adding control constructs into our model. For this exercise, we will use the EFFBD. If you prefer to use SysML representations, you could equivalently use the activity diagram. While the FFBD allows us to add constructs and functions to the diagram, items cannot be added directly through the diagram. However, EFFBD allows us to add constructs, functions, and items to the diagram directly, and thereby add them into the core system design repository. From the Project Explorer, select the function element Perform Autolink function. Click the EFFBD tab to open an EFFBD view. In the same manner that we used with the FFBD earlier, select the branch between the reference nodes at the insertion point. Insert a parallel AND construct with 4 branches. Next, we'll annotate each branch. Double-click on the top branch and type Navigation. Now, pause the video and add the remaining annotations as outlined in the chart on screen. Next, we'll add functions to each branch. Select the top branch labeled Navigation and click on the Insert Element icon. Now, pause the video and from the Insert Element dialog, create the 2 new functions listed on screen. Click OK to add these functions to the diagram in the order they were added to the target list. Now, pause the video again and add more functions as outlined in the table on screen, working 1 branch at a time. Now take a moment to compare your EFFBD to the one on screen, pausing the video if needed. To complete our control logic, we are going to add an iterate construct to the navigation branch. An iterate construct is a shorthand construct for a repeated sequence. It is controlled by a domain set, which defines the number of times or frequency with which a functional sequence repeats. On the navigation branch, select the function Compute Latitude Longitude. Click on the iterate icon. In the Domain Set dialog, double-click on the class Domain Set and type Position Recalculation Rate and click OK. Notice our iterate construct was placed to the left of the function. Selecting an object causes the insertion to be to the left of the object. Selecting a branch causes the insertion to be to the right of the selection. We need to move the 2 functions on this branch to inside the iterate construct. Select Compute Latitude Longitude. Shift-click on Integrate Current Position and Map. Ensure that only these 2 functions are highlighted and not the entire branch. Press Ctrl-X to cut the 2 functions. Select the branch portion within the iterate. Press Ctrl-V. This will insert the 2 functions inside the iterate. Now, let's number the functions on our EFFBD. Be sure that nothing is selected by clicking in the background. Then, right-click and select Renumber Element. A Renumber Element dialog is provided. You may keep the value suggested or change it to a new value. In this example, select 0 and click OK. Then Core will automatically renumber the functions. Inputs, outputs, and triggers can be added directly to functions in the EFFBD or activity diagram in the same manner as we used earlier with the N² diagram. Flows between functions can be defined by selecting the functions in the order of from to and using the Connect via Trigger or Connect via Data icons. Remember to hold down the Shift key when selecting from two connections. Individual function inputs, outputs, and triggers may be added with one of the edit icons. Note that triggers differ from input items and that they are required to be present before that function can begin execution, where inputs are not. Now pause the video and add items to the behavior model using the table on screen. Note that routing instructions and emergency notification requests do not yet exist as items and will need to be created. Icons on diagrams can be moved within their positioning constraints. To move an icon, first select the object. A move handle appears in the upper left corner of the object. To reposition the selected object, click the mouse within the handle and drag the object to the desired position. Pause the video and take a moment to explore how you can adjust the diagram. Align commands are also available for both horizontal and vertical alignment. Multiselect using the Shift-Click method all of the nodes you want to align, and click the desired alignment icon at the top of the diagram. In Core, with every action, you are building the underlying integrated model, and Core's view generators produce the desired representations. This allows you to switch between representations seamlessly upon demand, thus increasing the available tools to support your analysis and communication needs. Click on the Activity Diagram tab to view the information you just entered in the Activity Diagram view. Notice that I have already adjusted and aligned the icons on this diagram. Let's continue with the completion of the behavior model. We will decompose the function Assess Vehicle Health using the EFFBD to decompose this function. Click on the EFFBD tab to return to that view. Now hold down the Control key and double-click on the Assess Vehicle Health object. This opens a new window. Expand the window to fill the screen. Let's toggle off the reference nodes by selecting the Diagram Options icon. Remove the check mark next to Show Reference Nodes and click OK. Select the branch and click the Insert Element icon to add a function to the branch. In the Insert Element dialog, create a new function named Process Health and Status Information. Click OK to close the dialog and add the element to the EFFBD. We are going to make this function a multi-exit function by assigning it multiple exits. Select the function Process Health and Status Information and then click on the Edit Exit Conditions icon. Now pause the video and in the Edit Targets dialog create two exits, Accident and Normal. Click OK to close the Edit dialog. Next, we will add a function to the Accident branch. Select the Accident branch and click the Insert Element icon to add a function to the branch. In the Insert Element dialog, create a new function named Alert Customer Support. Add it to the Selections list and click OK to close the dialog. Now we will number the functions on the diagram. Click in the blue area of the diagram so that no object is selected. Then right mouse click and select Renumber Element. Click OK to keep the same number for Assess Vehicle Health. The new functions will be automatically renumbered. Let's now add items to our behavior diagram. Select the function Process Health and Status Information. Click on the Edit Triggers icon to add an item as a trigger. In the Edit Triggers dialog, select Health and Status and click OK. Next, select Alert Customer Support. Click on the Edit Outputs icon and add an item as an output. In the Edit Outputs dialog, select Emergency Notification Requests. Click Add and OK. Now that we have defined our system and its functional behavior model, let's extend the requirements traceability to identify the elements that fulfill each requirement. We will use the element browser to add these traceability relationships. First, close the EFFBD window. In the element browser, select the class requirement, and then the element ORD.1.1, impact detection. Double-click the basis of relationship to open the Edit Targets dialog. In the Edit Targets dialog, select Target Class Function. Select possible targets, process health and status information. You can drag and drop from the possible targets to the Targets pane. Also add Alert Customer Support. Click OK. Click on the Hierarchy tab in the Element browser and you will see the Traceability hierarchy diagram in place of the property sheet. You now see the traceability of the requirement down to the function level. Return to the property sheet using the Property Sheet tab. Pause the video and use the diagrams on screen to extend the traceability for these requirements. Note that 3 relationships are used here: basis of, specifies, and generates. The generates relationships were created previously during our analysis of the requirements. This concludes Part 8 of the guided tour. Part 9 will complete the physical model. If you have any questions or concerns, let me know. Email me at support@vitechcorp.com.